All right, so I'm going to talk about integrity management. And essentially the point of integrity management is within an organization detecting change, essentially, and managing change to your resources. So if you remember computer security, well, what are the three aspects of security that we usually use to talk about security? Yeah, confidentiality, integrity, and availability. So integrity, what's integrity about? Does anyone remember?
Knowing what the information is, the state and knowing when it's changed.
Yeah, no, but the modification is what we're interested in. So confidentiality is about whether or not someone can access something. Availability is whether or not the services that you want to provide are being provided, and integrity is whether the data that you have is reliable, and whether the changes to it are the changes that you want made to that data. So integrity is actually, in a lot of cases, most commercial companies, like most commercial organizations, integrity will be the highest, their main security goal. So availability might be important. So for example, Amazon or Google, availability is going to be pretty important. But most like commercial organizations are really going to want to make sure that the information that they have is reliable and hasn't changed without them wanting it to change. So can anyone give an example of an organization that might actually, confidentiality might be their main goal? So keeping things secret.
Banks.
Sorry?
Banks.
Banks? Yeah, they're going to want to keep things secret, but probably integrity is going to be more important to them.
Witness protection.
Yeah, like military, police, witness protection, yeah, they're good examples of where actually keeping things secret is the most important thing. But yeah, protecting integrity is often the most important, and banks would be an example of that, because a bank doesn't want you to know how much money someone else has. But is even more important is that the balance in your bank account is actually what it should be, because if you can change the balance of your bank account, then that's horrible. Whereas like the NSA, for example, they want to make sure they keep all their details secret. Someone might go in and alter their information, and to them that's better than if stuff gets leaked, for example. So it's all about preventing unauthorized changes. So making sure people can't go and delete the data that we have or modify it. So examples of that in terms of like IT is like someone could come along and add a new user to a system. Has anyone here like worked within the IT industry already? Like you've done something. I guess you guys are still like doing your undergraduate degree. But if you imagine, it wouldn't be that if you work somewhere and someone added a new user to one of the computers, do you think that anyone would notice? Like often the answer would be no. If they're not actively trying to manage the integrity of their systems, then those sorts of things can go right under the radar. So you want to make sure that people aren't able to add new users, but also if someone does, you want to know about it. And like deleting or changing log files, again, something that we really want to stop from happening. And if it does happen, we want to know about it. So what can we do to actually protect integrity? Well, it's so important that there are loads and loads of relevant security features. Within Windows or a Linux or Unix system, there's all sorts of controls. There's layers and layers of controls that can be used to try and protect this. So there's like standard file permissions. So on Windows or Linux, you can set permissions for individual files and who can access what. There's network controls which limit people's access to information. and services. So you might say, well, I've got this service, but only these people can connect to it. You have authentication, so whether someone can log into a computer in the first place, we'll be able to control, add a layer of security to stop them from getting onto it in order to add a new user to the system. So those are all layers of security, and ones that we'll look into in more detail later. Specifically for you guys, it'll be next semester. We'll look at all these defensive things in quite a lot of depth. But for now, we'll talk about some additional controls. So we're going to have a focus on the Unix side of things, but all these concepts apply to other operating systems as well. So there's a number of ways that you can control a file, control permissions on a file. On a Unix, there's abbreviated ACLs, access control lists. There's extended attributes, so you can set extra security flags and things for more advanced security features like SE Linux and file capabilities and all that sort of stuff. Again, this is stuff that you're going to learn about more later on. And there's also standard file attributes, and that's what we're going to talk about right now. So depending on what file system you're using, there are different attributes that you can set. And you can set a file on a Unix system or a Linux system to be immutable. And it's kind of like the analogy would be, you're basically putting it in a glass cabinet, so you can see the contents of the file, but no one on that system can actually write to that file or even delete that file. Even root user on the system, unless they change the file attribute, won't be allowed to make any changes to that file. So, and funnily enough, it's worth mentioning that this is a kind of a little known feature on a Linux system. So if you actually, even some sysadmins might be quite confused if you set a file to be immutable, and they're like, what? Even as root, I can't delete this file or alter it. So it's kind of one of those features that people are kind of aren't that aware of, but it's worth knowing about if you want to protect, set your system up to be as secure as possible. You can also set files to be append only. So what that means is, for example, a log file, you can set it so that you can write to the end of a file, but you can't change the contents within the file. So you can set the permissions so that you can add extra information, but you can't change anything within it. So it's perfect for a log file where that's what you want, right? You want things to be able to be added to the end. Again, obviously, if someone manages to get root access to a machine, they can just change the file attributes and then modify the file. But if you manage to keep, it is an extra layer of security. So if they only manage to get user access and they've got ability to append to the file, that's all they can do. Unless they can somehow get extra permissions on your computer somehow, you can basically control the fact that they can only write to the end of this file. So yeah, perfect for log files. Although it does depend on the fact that the program doing the logging is intelligent enough to not try and write to a file and actually do append to the file. So you might, you need to test the programs to make sure that it works with append only. So you can see here you can basically cat, which will accept things typed and send them to standard out. Forward that on to test is basically going to mean that you're typing into a file called test, press Control-D at the end, and it's created a new file called test. You do ls@attr, it'll list the attributes for that file, and you can see that you can ignore the E, basically it's just nothing. Then if you set that file to be immutable, so sudo change attribute +I, and then the name of the file, and then look at those attributes, you can see that flag has been added to it. And now at that point, no one can change that file. It's basically set. So if you can safely give people access to that file that are normal users, and they will be able to read the file and they won't be able to make any changes to it. Read-only file systems. So another thing that you can do, again, this is in addition to all the standard kinds of file permissions and things you can use. You could set an entire file system to be read-only. So you can mount a file system so that you can access the files off it but not change them. So it's similar, I guess, as if you remember, you probably can't remember this, some of you might, floppy disks, right? the diskettes, and there's a little switch on the side that you switch it to, like, read-only access or whatever. And then, if the computer's doing the right thing, it won't let you write to the file. So it's kind of like that, where you can mount a hard drive so that you can access that entire hard drive, but you can't change anything on the hard drive. And you can also, when you, like a CD, for example, or a DVD, when you put it in a computer, normally it will be mounted as read-only, because if that media is a read-only media, then you can access the stuff off the CD, but you can't obviously delete anything because it hasn't got the ability to write to that. Obviously nowadays, there are some exceptions to that, but generalized. So you guys have done forensics modules, obviously, so you know about even more advanced ways of doing this. So you can do it at a software layer, which is this, where you set it to read-only mounting, but you could also use write blockers and things like that, so that it physically stops any of the commands that would write to a hard drive from reaching the hard drive. But this is at a software layer, so that you basically tell the operating system, I want access to this drive, but don't try and write to it. So that can be a security feature. So you could have the main operating system boot off read-only memory in some cases, and have your home directory somewhere else that you can write to. So you might need to do a little bit of fiddling to make that work properly. But you look at live CDs and live DVDs. That's basically an example of that. So
why don't you just print all your logs out?
Why don't you?
Then people can't change them.
You can. You can print all your logs out. If like as I was saying the other week when we were talking about logging, some people actually do just have it set up so that all the log files just print out from the printer. But if you've seen some log files and the ridiculous amount of noise there is, would it be that helpful to have a stack of paper like this big with all of your syslog output in it, with all of every time someone's plugged in a USB and the computer started and it's loaded all the drivers and everything? Printing that out is going to be next to useless probably, unless something, it might come in handy one day, but just imagine the amount of paper you'd go through, and trying to find anything would be almost impossible. But maybe you could filter it down so that the really important stuff got printed out. And yeah, it's not a bad idea, but good luck trying to explain to a manager why your printer is constantly printing out stuff. It's like, yeah, it's really important. It's got all the sudo logs are just printed out just in case we need it. There might be other approaches, but yeah, you could do that. Alternatively, you could write to a network or something like that. Keep backups. Okay. Right, there are some ways that you can circumvent a read-only mounting. So, for example, you could mount something read-only, and if someone manages to if the attacker manages to get root, they could access that drive another way, via the device file, for example, instead of where it's mounted. So again, these features, a lot of these security features work unless the attacker manages to get root on your system. But they're layers of security. Because if you do things right, you can assume that the attacker isn't root in order for certain security features to work. So, if a normal user is using a system, you want to control how much access they've got in case they have some vulnerable software or malware, or they're trying to do something bad. You can limit what kind of damage they can do. So it's one thing to try and protect these things, but as we've said all along in this module, at some point things are going to go wrong. So you do what you can to protect your system, you do what you can to set things up securely, but it's foolish to believe that you're never going to have a compromise, a security problem, because if the likes of pretty much every big company I can think of off the top of my head has had major security breaches, so in the past couple of years, there have been, on one level or another, Apple's iCloud incident. There's, Google's Gmail a while ago. There's Facebook's staff account got hacked a while ago. There's Adobe, all their user details, and Sony, same thing. And so these are companies that obviously have a lot of resources, right? And the only reason we know about it is because they're such high-profile cases that people are very interested when it happens. So to think that these big companies are going to make a mistake, that a smaller company is never going to make a mistake, the same kind of mistake, is probably nowadays we have to accept that something's going to go wrong at some point. We do everything we can to stop it. Well, everything within reason of your cost-benefit analysis to stop it, but then eventually something's going to go wrong. So how do we detect that something's changed in our system, or how do we detect that we've been hacked? One way that we can do that is to actually monitor the activity on a local system, and that's a host-based intrusion detection system. So if you remember when we were talking about intrusion detection systems, we're talking about Snort and things like that. Those are network-based intrusion detection systems where we're looking at network traffic and at like a multiple user view of things, looking at stuff that's happening on the network and it looks like an attack's happening. In this case, what we're talking about is looking at the changes that are happening on a local computer. So for example, these files have changed in certain ways, or this program's trying to do something or other. That's host-based intrusion detection system. So the simplest way that we could detect changes is to basically compare files to a known good state. So that could be quite easy. If we keep a complete backup of everything on our computer, we could basically compare everything on our computer to everything in the last backup and see what's changed. We can say, okay, since the last time we did a backup, these files have changed. And that could work. It shouldn't be the only backup we have, obviously. If the backup that we're accessing all the time, we should have a secure backup in addition to that. But say we might have a network share that is read-only, that shows us our last backup that we can use to compare the current system to. You could figure out what's changed that way. It's quite slow and tedious because you need to run through, access both files, both copies of the file at once, run through and actually compare them. That's quite disk intensive because you're accessing 2 entire copies of each file every single time, and to do those comparisons is a lot of work, but it's one way you could go about doing it. So a program that you could use to do that is Diff, and what Diff does is it compares 2 files or directories of files. It's used commonly in programming to create patches between 2 versions of a program. So if you're writing some software, you can use Diff and it will just show you the lines that have changed. So for your final year projects, if you are doing programming and you're using existing code, that's one way that you could show what your changes were to the code that you're basing it on. You can use Diff and it will show you the lines that you've changed. And the way you do it, you basically diff and then the good file and the new file, and it will show you how things have changed since then. So Rsync is a network copying tool, so you can use it to sync across the network, make backups and things. It's a really powerful tool, and I think we'll talk about that more later in the semester. But you can use it to detect changes as well, because it does some clever stuff over the network to limit how much stuff gets copied. But you can basically say, Rsync, if you were going to copy this file onto the network, what changes would there be that you would need to copy? And you can say -n, so do basically a dry run, don't actually make any changes, and it will go through and list all the files that have changed. And it does it a lot faster than using Diff, because if it sees, for example, it does certain things to check whether it thinks that you're going to need to change it. So look at things like modified date and the size of the file and things like that. So so that's one way that you can quickly check whether files have changed. A more reliable way of checking where the files have changed is you are using one-way hash functions, so cryptographic one-way hash functions, which as forensic students you guys will all know everything about. Well, you'll know what they're used for. So just to remind you, basically a one-way hash function, you can take a file of any length, it processes all that information and it comes out with a fixed size, looks like a random string, but it's deterministic, so it's based on all that input. And if you change a single thing within all of that input, it'll come up with a completely different hash. And theoretically, it shouldn't be possible for you to come up with a different set of input that gives you the same hash. So that's the strength of it. You can basically say, if you compare the hashes of these two files and they're the same, then you can say with great confidence, if it's a good one-way hash function, that it is exactly the same file. It's got the same contents, and it should be theoretically impossible for an attacker to trick the hash function. Obviously, there are hash functions that we used to think were really good, and now we know aren't great. So MD5 is one of them that is now considered broken, that we shouldn't be using anymore. Because people have found collisions and things like that. But just in general, if you use a good one-way hash function, you can be very confident in it. So,
which one would you recommend to use?
Later, newer versions of SHA is good. SHA-1, people are starting to say it's time to move on. Yeah, and that's considered to be a good option. Yeah, and SHA-3, I believe, has been released, or it was a standard that they were standardizing on, and I believe they've even released version 3 now. If not, it'll be very soon. And that, even though there's nothing proven to be wrong in the SHA-2 family, there's even another option that you can use. So we can basically compare. So if we store the, okay, so what would be the advantage of using hashes instead of comparing to a complete backup of a file? Quicker? Why is it quicker?
Because you transfer that hash, what SHA is it, 14, 18 digits?
Yeah, it depends on which.
Rather than comparing say 4 meg images.
Yeah. Yeah. So what you can do, you're right. So on the network, you might just have this stored somewhere, which is the copy that we know is the correct one. And then if we have, we just need to generate a new hash of the current file. And if they're the same, then you're right, we don't have to do as much work because you don't have to load the entire other file over the network, compare the entire length of that file. It's a lot quicker. What might be a disadvantage of doing it that way? Anyone think of something that we might not be able to know about doing it that way?
If you're just storing the hash.
Yeah.
There's no identifying what file actually is until you compare it.
Well, you wouldn't know permission changes.
That's true. You wouldn't know if the file permissions have changed and metadata and stuff like that. That's a good point. Yeah.
You'd only know if the file was changed. You wouldn't know any specifics to do it.
Exactly. Yeah. So all you know is that the file's changed somehow. If that's all you've got, those two hashes. If it's changed, you know that file has changed, but you don't know how. You don't even know what the file is unless you go and look at it. I guess unless the name's obvious. But as you were saying, so you can't actually tell how the file's changed. But it is a lot faster. So it's a good idea to be able to do both. So if you've got the hash, you can see something's changed, and then if you need to, you could always refer back to a backup to actually compare to figure out exactly how has it changed. So we just store the hash. When we recompute, we can tell whether or not it's changed. So if the hash is different, then the file's changed. If the hash is the same, then the file is exactly the same. We can use that to detect any changes, including corruption. So, for example, when you download an ISO image off a website, so you download a Linux distro or whatever, it'll often give you a hash that you can use to compare your download in case the download's been corrupted. So if you're not sure, you've just downloaded 4 gigabytes of data, you can generate the hash, and if it's the same, then you know that the download has succeeded. Because sometimes it does get corrupted because something will get messed up in the download. Okay, so what programs can we use to actually do hashes? So there's shasum. It uses SHA-1 by default, but you can also call these different SHA versions of the program, and it will actually use the different versions of SHA-2. So you can do things like do SHA-SUM or SHA-1 sum etc password, and it will generate a hash of that file. You can actually just type SHA-SUM and start typing away and press Control-D to end, and it will generate a hash of whatever you've typed into it. So you can use it to hash anything. You can use it then, once you've done that, you can also use SHA-SUM to compare your hashes with the current state of the system. So you can use the program to generate a bunch of hashes, and then you can use it to compare your current system with a list of hashes that you've got. So you can basically run SHA-SUM -c and then whatever the file is that you've stored all your hashes, and then that will show you whether the files currently match the way they were when you generated the hashes. If I saved my database, my list of hashes in my home directory, and then thought I might have got hacked, and then compare that list of hashes with the current way the system is, why would that be a horrible idea?
Because if it's in the home system itself, it doesn't need root to change. But
Yeah.
the file itself, or say if the files are there that
Yeah.
hash them, someone could just go in and change it because they don't
Yeah.
need root access to it. They could just get a simple user.
Yeah. Well, yeah, if they've got my user, then they probably, if they get access to my user account, then you're right, as you say, they could change the database, and then say they did get root access to the system, they changed a whole bunch of stuff, they could just regenerate the database, sit it on the computer, and then when I come along and check it, it says everything's fine. So you need to actually protect the integrity of your integrity checking tools, obviously. So there are tools that are designed with a lot more features that you can use to do integrity checking. So Tripwire was probably the first really famous version, and originally it was open source, and then they closed it and created a proprietary version, which is now a big commercial enterprise doing all sorts of fancy things, more than just the file integrity checking, but they do like log management and all that sort of stuff. There's also advanced intrusion detection environments, OS sec, and a bunch of other things. BSD includes a command called mtree, which essentially does the same kind of thing. So some of these programs do things like rootkit detection, log analysis. Sometimes they've got stealth features to hide themselves, so that if someone does hack into your computer, they hopefully won't notice that you're monitoring integrity, so that they don't try and mess with that system. So yeah, it's a form of host-based intrusion detection system. This is just a simple little script written in Perl that basically does the same thing, where you might just have an array, in this case associative array of paths to hashes, and then you can just go through in the loop and generate a new hash and compare whether or not it's the same as the old one. If it's changed, you warn the user, otherwise you don't, because all is well. So it's just a little example of a way that you can monitor your system for changes. Another thing you can do on Linux systems is the package management. Includes hashes often. So with RPM, for example, based systems, you can check whether all the packages, the files have changed since you've installed a package, and that can be quite a helpful little tool that you can use, because if the software, if you trust your repositories, so you trust the packages, like the collections of software that you've installed, then you're not that worried about that. You just want to know about the ways that those files have changed or the other stuff. So you can use RPM to actually verify and detect you can detect what package provides a certain file, and then you can basically query it to see whether or not anything's changed. So you can verify all the packages on the system with this command on an RPM-based system, so like Red Hat or OpenSUSE. I guess the limitation is that the database doesn't include information about every file, just the files that were installed by default by the actual operating system. And maybe the RPM program gets tampered with because it's sitting on the computer that you're trying to check. So some of the weaknesses with all these tools is that the tool might have been Trojanized, right? If you're running a Trojan horse, it might pretend like everything's fine, but if you've been hacked, you need to be dubious of all of the software that's on that computer. So you might run the software, the integrity checking tools from the network instead of directly on the computer. And even then, maybe the operating system itself's being compromised and is lying. So you might want to, if there's a rootkit on your system, probably you need to turn the computer off and just do the analysis on the hard drive instead of via the software. But it depends. You're not going to want to turn a server off if you don't have to. So you are going to rely on some of those user space tools to just do the first layer, level of checking. So some of the other sorts of things, which was a good point earlier that someone made, I think it was Dan, pointed out that permissions and things aren't going to be detected, aren't going to be detected if you change those things. That's something else you might want to keep track of. You also want to detect changes to local processes and things. That can be really hard to do. And obviously you need to keep monitoring system logs and network availability and everything. So in conclusion, detecting changes to our systems is really important. There's a number of ways we can do that, including using full comparisons and using hashes. And all of this is a form of host-based intrusion detection system. There's a reading there that I would recommend if you want to check it out. And so that's integrity management. Okay, great.
I thought that last